Hi, this is Runit Vashish with Amazon Web Services. In this session, I'm going to talk about deploying ASP.NET web applications to Amazon Elastic Kubernetes Services, or EKS, using AWS Code Suite. I will start with introduction to Amazon EKS service. What is EKS and what is it used for? Then I will talk about AWS Developer Tool Services and AWS Code Suite, which comprises of services such as code commit, code build, and code pipeline. I will then set up an EKS cluster and build and deploy an ASP.NET Core web application onto that EKS cluster. So what is EKS? EKS is a managed service that makes it easy for you to run Kubernetes on AWS without needing to install and operate your own Kubernetes control plane or worker nodes. Kubernetes is an open source software that allows you to deploy and manage containerized applications at scale. Kubernetes groups containers into logical groupings for management and discoverability, then launches them onto a cluster of compute or EC2 instances. Using Kubernetes, you can containerize applications including microservices and batch processing workers. When you create an EKS cluster, you will get a cluster CNAME like this. This represents your cluster's ID. And when you deploy your worker nodes, they will connect into this cluster by connecting directly to that CNAME. When you want to connect to that cluster, you'll configure Kubernetes config file or kubeconfig. That kubeconfig file will then be referenced by the command line tool for Kubernetes called kubectl or kubecontrol. This CNAME represents managed control plane for your EKS cluster and allows you to send operations that would tell Kubernetes to schedule containers for you. When you create a cluster, you usually go through a couple of steps. First step is to set up an environment, which involves setting up VPC, subnets, internet gateway, or any other AWS infrastructure items required to make your clusters work. Second step is to create an EKS cluster. This will create a highly available control plane and managed node groups. With Amazon EKS managed node groups, you don't need to separately provision or register the Amazon EC2 instances that provide compute capacity to run your Kubernetes applications. All managed nodes are provisioned as part of an Amazon EC2 autoscaling group that is managed for you by Amazon EKS. Last step is to deploy your workloads onto your EKS cluster. You will have full control over how you build your application on top of this cluster. You have multiple options to get started with setting up your cluster. Options such as AWS CloudFormation, which automates a lot of steps involved in setting up the environment and the EKS cluster. Other option is to use command line tool called EKSCTL. It is a CLI which can automate provisioning your cluster for you. You can also use one of the partner solutions like Terraform, Plumi, Rancher, and many other to deploy cluster using these tools. For this session, I have already created an EKS cluster using instructions in this user guide. I will include a link to this guide towards the end of this session. This guide walks you through the steps required to set up your EKS environment and EKS cluster using CLI tool called EKSCTL. It covers all the prerequisites such as setting up AWS CLI and many other tools which are required to set up your cluster. I am now in my Cloud9 terminal window from where I can access my EKS cluster. Let us look at some of the details of this cluster. From the terminal, I can do kubectl and I can look at the cluster info. I can use kubectl get nodes to find out all the worker nodes in my current cluster, which in this case is 3 nodes. I don't have any application deployed, but I can still run get deployments to see if there is any resource, and in this case it's none. Similarly, I can check all the services which are currently running, and in this case I don't have any application running. Now what I want to do is, before I start using code suite, I want to deploy one simple web application using my CLI tools. I have defined my application deployment in a file called hello world deployment.yaml. This is the deployment configuration, and a few important things to call out. This is the deployment configuration, hence the name deployment. I'm going to run 3 replicas of this application, and my application will be served from a Docker image which is stored on my ECR repository listed here. ECR is Elastic Container Repository. ECR is a managed repository service which can be used to deploy your Docker images. My application will be running on port 80, and the next configuration is my service configuration. This is doing the port mapping, as well as it is configuring my load balancer, and the service name is going to be hello world. So let's go ahead and configure this service. I'm going to use kubectl apply, and I'm going to give path of both of my configuration files, my deployment configuration and my service configuration. Once my deployment and service configuration is created, I should be able to look at the services and deployments. It's going to take a second. Okay, my deployment and service is configured now. I can look at my deployments and the services by using get deployment. Here I can see I have 3 of my deployments ready. Similarly, I can look at the service description as well. Now, since my service is behind a load balancer, I can get the URL of my load balancer, or I can go back to my Ec2 console. And if I refresh my load balancers, I can see my load balancer is already created. And if I look at the instances, I see my instances are currently showing out of service. It's going to take a few minutes before my instances will be back up into service. After waiting for a minute or so, my instances are in service now. I can go back to my Cloud9 console, and I can get the grab of my I can grab the DNS of my load balancer, or I can do the same thing from my load balancer description as well. And if I go to the browser and try to open the link, I can see a hello world application running now. So with this, we have just deployed a hello world application on our Eks cluster from the Cloud9 terminal using eksctl. Though I have a functional hello world application running on my Eks cluster, my goal is to set up a deployment automation for my ASP.NET Core web app, right from the source code to a running app on an Eks cluster. For this, I'm going to use AWS Code Suite services, which are part of AWS Developer Tools. AWS Developer Tools and Services provides multiple options to host the code, build, test, and deploy your application to AWS. The AWS Developer Tools are built to work with AWS, making it easier for your team to get set up and be productive. Few of these tools and services that we will use in this session are AWS Code Commit, Code Build, and Code Pipeline. AWS Code Commit is a fully managed source control service that hosts secure Git-based repositories. It makes it easier for teams to collaborate on code in a secure and highly scalable ecosystem. Code Build is a fully managed continuous integration service that compiles source code, runs tests, and produces software packages that are ready to deploy. With Code Build, you don't need to provision, manage, and scale your own build servers. AWS Code Pipeline is a fully managed continuous delivery service that helps you automate your release pipeline for fast and reliable application and infrastructure updates. Based on the release model you define, Code Pipeline automates the release process every time there's a code change. The first code suite service that I'm going to use today is called Code Commit. To get started with the Code Commit, scroll down on AWS Management Console and click on Code Commit under Developer Tools. Once you are in Code Commit Console, click on Create Repository and give your repository a name. In my case, I'm calling my repository ASP.NET EKS Demo. Once you've given the name, click on Create. And that's pretty much it. Our source code repository is ready to be used. This is a Git-based repository to which we can connect from any of the Git clients. If you're planning to use Code Commit with Visual Studio, there are a couple of additional steps required. Here's a user guide to integrate Code Commit with Visual Studio. You would need to create an IAM user and install AWS Toolkit for Visual Studio to get started with Code Commit. I'm going to include a link to this user guide towards the end of this video. I have already connected my Visual Studio with my Code Commit instance, and I have already committed the sample application, the boilerplate ASP.NET Core web application, to my source code repo. This is my source code repo, and you can see my code is already here. This is the standard application, as I mentioned, with no specific changes to the boilerplate code. I have included two additional files. First one is buildspec.yaml and another one is called hellok8s.yaml. Buildspec is my build specification that will be used in next step. Buildspec is a file which is used by Code Build to build my application, and my hellok8s.yaml file will be used to deploy my Kubernetes application on Eks Cluster. Let's take a look at buildspec.yaml. Here is the buildspec.yaml file which I'm using for my project. I have this build spec open on my local machine. This build spec I have created using examples given in EKS labs. This is the EKS workshop or the EKS lab. If you are new to EKS, I will strongly encourage you to take a look at this publicly available lab. I will share a link to this lab towards the end of my session. Back in buildspec.yaml, the build spec has multiple steps which are executed by Code Build at the time of building the application. Let's take a look at a few of these important steps. The first one is the installation stage. This is where following steps or the selected steps will be executed by Code Build. The first step here is setting up AWS IAM Authenticator. Amazon ECS uses Identity and Access Management Service, or IAM, to provide authentication to your Kubernetes cluster through the AWS IAM Authenticator for Kubernetes. You can configure the stock kubectl client to work with Amazon EKS by installing the AWS IAM Authenticator for Kubernetes and modifying your kubectl configuration file to use it for authentication. In the next step, I'm setting up my kubectl, then setting up execute permissions as required. setting up path to the present working directory, then installing a couple of utilities like JQ, and then upgrading my AWS CLI. Once done with the installation stage, the build will move to the pre-build stage. The first step in the pre-build stage is setting up tag, which is equivalent to $repository name. $repository name is the environment variable which will be passed to the code build definition. And then appending repository branch and environment names. These are also variables, environment variables, which are passed to code build. Once tag is set up, in the next line, what I'm doing is I am replacing a string called container underscore image in my hello-k8s.yaml with the full repository URI appended with $tag. After that, the next step is to set up a login to ECR. ECR is where I'm going to push my Docker image in the post-build stage. The next major stage is the build stage. This is where my Docker build will actually execute, and it will tag the Docker image with $repository URI $tag. Repository URI will be passed as environment variable, and $tag is set up in the pre-build stage. Once the build stage has succeeded, code build will execute steps or the commands in the post-build stage. The first one is pushing the Docker image to remote ECR repo. Once that is done, the next important step is before we can start deploying our application to our Eks cluster, we need to assume a role which has required permissions to connect to Eks cluster. For that, we're going to execute AWS STS assume role. For that, we're going to use a role name which will be passed to our code build definition as an environment variable, which in this case is EKS kubectl role ARN. Once the STS assume role has succeeded, we are going to set up some AWS configuration variables like access key, secret access, session token, etc. After setting up AWS config values, the next setup is to update kubeconfig. In this case, I'm passing the cluster name, which will be passed to the build configuration as an environment variable. Optionally, you can also set up a region. In case your build and your EKS cluster are in the same region, you don't need to pass this value. I'm then executing my cluster info. This is not required. You can use this just to make sure that your configuration was updated correctly and you can connect to the right EKS cluster. The last important step is to apply the configuration changes, which are in hello-k8s.yaml in this case. Let's take a look at this hello-k8s config file, because that is a configuration that will be applied to our EKS cluster. Here is my hello-k8s.yaml file. This file has two different parts. The first one is my service configuration. As you can see, it is a lot similar to the service configuration that we saw earlier. I have my service name, my service selector, and type as load balancer, and then port mapping. And if I scroll down, I can see my deployment configuration. This is also a lot similar to the configuration that we saw earlier. The important thing to notice here is that my container runs on port 80, and the image here is a placeholder string called container underscore image. This placeholder is replaced at the runtime by my build spec. You can see here, back in the build spec, in the pre-build stage, I'm replacing container underscore image with $repository $tag. To create our build automation, we have to create a new build project using code build service. For that, back in your management console, scroll down to developer tools and click on code build. Once you're in code build, click on create build project. give it a name. In my case, I'm calling it ASP.NET EKS demo. Now let's configure the source for this build, which in my case is code commit. I could select other code providers, source providers like GitHub, and code build also supports Bitbucket and GitHub Enterprise as well as S3. With code commit selected, I'm going to select my repo, which is ASP.NET EKS demo, my branch, which is the default master branch in this case. Then I have to configure the environment. To configure my environment, I'm going to first select the operating system, which I'm selecting Ubuntu, runtime as standard, and I want to go with the standard 4.0 image. You can either leave to default, which is always to use latest image, or I'm specifically selecting the latest one, which is 20.06.15. Check the privilege checkbox. This is required to run all the Docker commands which we're executing during our build stage, like Docker build and Docker push. Our code build will be executed in the context of an IAM role. You can choose to create an IAM role. In my case, I already have created a role which is called as EKS admin. So I'm just going to search for that role and select that one. In my case, all the steps which I want to execute during my build stage are defined in the build spec. So I'm going to check this box as it is. I also need to define back in the environment stage, I also need to define my environment variables, which my build spec is going to use. I'm leaving them as it is right now. I'm going to come back, fill these variables, and then show it to you. So I have populated the environment variables. Let's take a look at them. The first one is called EKS cluster name. This is the name of EKS cluster that the build stage will use to connect to. The next one is my repository URI. This is the Docker repository URI where my Docker image will be pushed. In my case, this is the URI to my ECR repository. The next one is EKS kubectl role ARN. This is the role which my build execution will assume. This role has to be an IAM role which has required permissions to connect to the EKS cluster, or it should be the role which was used to create the cluster in first place. The next one is the name of repository and my repository branch. I'm using these two environment variables to create the tags which will be used to push my Docker image. With these attributes all set and leaving the rest of the configuration settings as is, I'm clicking on Create Build Project. Once my Create Build Project is ready, I'm going to click on Start Build and click on Start Build. The build execution is take a couple of minutes. I can see the progress under build logs. Let me pause the video and come back once the execution has completed. It took a couple of minutes, but my build status has changed from in progress to succeeded. If I scroll down, I can see details of all the steps which were executed by code build. This includes all the installation steps, pre-build steps, build steps, as well as post-build steps. I can verify that everything went fine by scrolling on this page. Now, to look at my deployment, let me switch over to my Cloud9 IDE. I am now in my Cloud9 environment, which is connected to my EKS cluster. I'm going to run kubectl get services. This should show me a list of all the services which are currently running on the cluster. And I can see that my service ECS demo frontend is currently running on this load balancer. I can see the URI of my load balancer as well. Let's do the same thing for my deployments as well. I can run kubectl get deployments, and I can see my application with the name demo frontend is also up and running. Let's take a look at this load balancer from Ec2 Console. I switch over to my Ec2 Console, and on the left hand side, if I click on load balancers, I can see this load balancer up and running. Looking at the instances, I can see all 3 instances are in service. These are 3 worker nodes. Back in the description, I'm going to copy the DNS name and open it in a new tab. And yes, I can see the newer version of application up and running. This is the version of application which is running my ASP.NET Core web application. This is the boilerplate code then, and the only thing which I modified in my code was adding this string called welcome to code pipeline. Also, if I go back to my EC2 console and search for ECR, and click on repositories. If I click on my web app, which is the name of repository that I was using, and I can see the latest version of image was uploaded recently. And this was the name of image. And then there was a tag which was appended. With my source code in code commit and my build automation done by code build, I'm now ready to tie them together using code pipeline. For that, back in AWS Management Console, scroll down to Developer Tools and click on Code Pipeline. In the code pipeline, I'm going to create a new pipeline and give it a name, EKS Demo 1. I'm okay with creation of a new service role and click on Next. In my case, the source provider is code commit. I want code pipeline to monitor my code repo, specifically my master branch. With that selected, click on Next. My build provider is code build. We have just created a build definition called EKS Demo 1. With that selected and everything else kept to as default, click Next. Right now, my deployment steps are part of code build. So I'm going to skip the deploy stage. With all of this set up, click on Create Pipeline. It's going to take a couple of seconds and my pipeline should be up and running. As soon as I create a pipeline, my changes will be triggered. Right now you can see my pipeline is already in progress. After waiting for a couple of minutes, I can see that both the stages of my code pipeline have completed successfully. To do the recap, we started this session by creating a code commit repo and by checking in our ASP.NET Core web application project. It was a standard boilerplate project with not many changes. 2 additional files which I've checked in along with my project. The first one is buildspec.yaml. Buildspec is the build specification. It contains all the steps which will be executed by code build at the time of running the build. The second is hello-k8s.yaml. This contains both the deployment as well as service configuration. This configuration file is applied to my Eks cluster once the Docker image containing my application is created and pushed to the ECR repository. It's not very uncommon to break down your build step into further substeps. You may like to do your build and deployment separately. To illustrate that, our DevOps team at AWS has created this sample application. In this application, you can extend your code pipeline and break your build stage into build and deployment separately using AWS Lambda. With that, I've come to the end of this session. Here's the list of resources that I referenced throughout the session. I hope you found this session useful. Thank you.